Hello everybody, this is Unit 3, Day 7. Day 7, okay? And so we're going to be discussing the review, or we're going to be discussing simplifying square roots and imaginary numbers, okay? But before we dive into that, it's worth noting how to simplify radicals first, okay? So first part of the lesson involves just simplifying the radicals, and then we'll move into imaginary numbers and stuff like that, okay? So when you're simplifying simplifying square roots, okay, process I usually teach kids is the prime factorization, right? Or the hockey stick method. Okay, so here's how the hockey stick method works, right? Take a look at this 147. We say, okay, which one of these numbers goes into 147? Okay, so in this case, 3 does. It's actually 3 times 49. Okay, well, what goes into 49? Well, not 3 anymore. 7 does. So we get 7 times 7. So here's our hockey stick. And so any pair that you see, I see one pair of 7s, I bring that out of the radical. So I get 3 times 7, and then whatever I have left stays underneath there. If I don't have any pairs, so in this case 3 doesn't have any pairs, so it stays underneath the radical, and then we end up with 21 square root 3. Okay, so that's our first one. Letter B. All right. In this one, to make my life a little easier, I'm going to divide that 6 by 2, right? So we end up getting 3 square root 242. Okay? So again, I'm going to use the hockey stick method. Okay, 2, 3, 5, 7, and 11. And so what goes into 242? Well, it's a large number, but I know it's even, so I'm going to divide it by 2. And lo and behold, what do I get? 121. Okay, so 11 goes in there, right? How many times? Twice. 121 is actually one of our perfect squares. So here is a pair of 11s. I bring that out, so I get 3 times 11. And what gets left behind is the 2. So I get 33 square root 2. Okay, and notice I'm leaving it in radical form. Okay, so in all these problems, and today we're going to be doing the same. We're not going to be finding the decimal number for that. We're just going to leave it in radical form. Okay, so imaginary numbers. What are imaginary numbers, right? Well, so far we've seen imaginary numbers represented by negative numbers underneath the radical. Okay, so all right, which is nice. They give us, it's imaginary. We use the letter I, right? So that makes sense. But this imaginary numbers are equal to the square root of negative 1. Okay? And so how does that apply in terms of A, B, C, or D? Okay? So we're going to use this as a way to simplify these square root numbers here. So we can actually give them some sort of value, all right? Technically, they still have a value here, but we don't like to leave these like these, right? We don't leave negatives underneath the radical. So we convert them to imaginary numbers, right? Because they are, in this case, they are numbers that aren't represented on our, when we're finding our discriminant, when we're finding our roots, okay? It was our discriminant, right? So if we had a negative discriminant, it meant that we didn't have any roots. So, and that's pretty much what we're using for so far in this, or used them so far in this unit. Okay, so anyway, I'm gonna stop talking. Shut up, Mr. Kaya. All right, here we go. Okay, so square root negative 5, right? Well, that's just equal to negative 1 times 5, right? Okay, I didn't change the value underneath the radical. All I did was kind of separate it out. Okay, I'm going to use my rules of radicals to separate that even further, right? Again, I didn't change the value of anything up in the top. This would still equal negative square root of 5, right? Anytime you have radicals, you can just pull them together and then multiply them. I'm kind of going opposite. I'm kind of pulling them apart, right? But we do have a value for this, though. This negative 1 underneath the radical, right? It's actually equal to I. Okay, so our answer is just going to be I square root 5. And in most cases, we do write the we do prefer the I value to be behind the number. Okay, so we're going to write this as square root 5 pi. Okay? And that's all we had to do for this one. That's all we have to do for all of these, right? So the first thing you want to do is kind of pull out that negative 1 underneath the radical, right? So I'm going to do the same thing here. Negative 1 times square root of 2. This is just equal to I times square root of 2. So we get square root of 2, comma, I. All right? Let's move on to the letter C. Okay? Bring out that negative 1 again. Negative 1 times 36. Negative 1 times square root of 36. Again, this is just equal to I, but also square root of 36 is equal to 6. So our answer is just 6I. And finally, right, as we go over to the last one here, same process, just bring out that negative sign. Anytime I see a negative sign, I just bring out an I. So I got 3I square root 18. All right, hockey stick method, 2 and 9, 3 and 3. There's our hockey stick. So I bring out a 3. Whoops. Two gets left behind. And my answer ends up being 9I square root of 2. Okay? And so that is my answers for A, B. Those are my answers for A, B, C, and D. Okay? Now let's talk about the cycle of I. Okay? Because not always are we just left with I to the first power, right? Sometimes we're left with I to the second or I to the third. Or as you can see down below, we got I's raised to, 99, 300, 246. Okay? So, in order to simplify those, we have to know what the cycle of I is first. Okay? So as you can see, here's our cycle, right, which means we just repeat these 4 particular numbers. Okay? So I to whatever power is equal to only those 4 options. Okay? So how do we determine that? Well, first we want to start by dividing the exponent by 4. Okay? And so I'm going to have a list right here, x to the 0 power first. Well, actually, I'm not going to do those. How about x to the 5th? X to the 10th. Okay? So I'll get to those in just a second. All right? But over in this chart here, okay, I want you to put at the top remainder. Okay? Because the remainder, by dividing by 4, determines what your value of I is. Oh, did I put X there? Jeepers. I. Okay? So, let's start when you got a remainder of 0, right? Well, a remainder of 0 just means you got I to the 0th power, which is just 1. Remember, anything raised to the 0 power is 1, right? So 300 raised to the 0 power is just a 1, okay? X raised to the 0 power is just a 1, all right? Anyway, moving on. If you get a remainder of 0.25, well, that means you got an I to the 1st power, and I to the 1st power is just I, right? And you can kind of follow along in the cycle over there to the left. All right, 0.5, if you get a remainder of 0.5, that means we got I squared, which means I squared is equal to a negative 1. 0.75, I get I cubed, right? And I cubed is just equal to a negative I. All right, and that is it. And then the cycle goes back through. All right, so if I have I to the 5th power, all right, well, 5 divided by 4 is 1.25, so I got a remainder. Let me just do it up here. 1.25, so it's a remainder of 0.25. So I to the 5th power is just equal to I. Well, I to the 6th power. All right, well, 6 divided by 4 gives me 1.5. And so with a remainder of 0.5, that means I to the 6th power is just equal to I squared, which is just equal to a -1. All right, I to the 7th, 7 divided by 4, 1.75. And you get a remainder of 0.75. That means our I is equal, or I to the 7th is equal to I to the 3rd. All right, and we're just left with a -I. And then I to the 8th, well, 8 divided by 4 is 2 with a remainder of 0. And then we start right back at the cycle. And so when you have a remainder of 0, that means you got an I to the 0th power, which means you're left with just a 1. Okay? And keep going. So we go 9 to the 4th, which is equal to 2.25. So we get an I, and then 9, or a 10 divided by 4, 2.5. And we're left with a -1. And the cycle keeps going. Okay, so you're looking at that exponent, you're dividing it by 4, and then whatever your remainder is determines what your value of I is. Okay, and this will make more sense at the end of the problem here, because the fact of the matter is that we don't want I's floating around with such large exponents. Okay, these can all be simplified, so that's what we're trying to accomplish. All right, so I to the 12th. Well, 12 divided by 4. That's just 3 with a remainder of 0. And so I to the 12th is just equal to I to the 0th power, which is just equal to 1. Okay, how about 14? 14 divided by 4. Okay, looks like we get a 3.5. Right, it's a remainder of 0.5. That means I to the 14th power is the same value as I squared, which is equal to a -1. Okay, problems like number 3. All right, process this is the same, but you just want to make sure that you don't lose that 5. Right, so we get 5 times. All right, let's see, 99 divided by 4. I don't know what that is off the top of my head. We get 24. Whoops, let me do it down below here. Get 24.75, right? So you got a remainder of 0.75, which means I to the 99th power is just equal to I to the 3rd, which is equal to a -I. So I get 5 times -I, which is equal to a -5I. Same process over here, except we're just left with an x. So x times what? Well, 300 divided by 4. I think that equals 75. Cool. 75 with a remainder of 0. Okay, so I to the 300 is just a I to the 0th power, which is just a 1. So we get x times 1, which is just a x. And finally, 246 divided by 4, 61.5. It's a remainder of 0.5, so that means I to the 246th power is equal to I squared, which I squared is equal to a -1. Okay, let's keep going. All right, down here, we're multiplying them out. That's okay, just involves more rules with our exponents. So anytime you're multiplying with the same base, or when you're multiplying exponents that have the same base, you add the exponents. So we end up getting I to the 27th power, which 27 divided by 4 should be 6.75, if I'm not mistaken. .75. So you have a remainder of 0.75, which means I to the 27th is just equal to I to the 3rd, which is equal to a -I. All right, let's keep going. All right, here, all right, I got a 2x and a 3 in the front, so that's just going to be 6x. And then I squared times I cubed will give me I to the 5th. 5 divided by 4 is 1.25. So that means that I to the 5th is just equal to 1. I'm sorry, not 1. I. And so our answer is 6xi. Over here, 3i cubed, okay? Multiplying that by itself twice, so I get 9, and I get I to the 6th power. All right, well, 6 divided by 4, it's 1.5. So remainder of 0.5, so I to the 6th is just equal to, I lost my chart, negative 1. Because remember, this is going to be I squared. And I squared is equal to negative 1. So my answer is negative 9. We're going to skip number 9, and we're going to head right into the next one. Actually, we'll do number 9. Why not? What the heck? Show number 9 some love here. Okay, so it appears. Okay, now remember when we're adding things, we need to have like bases. So the only two we can add together looks like these two, right? Xi to the 20th, Xi to the 14th. Oh, no, we can't add those together. Duh. Okay. Because they don't have the same exponents. It's fine. All right. X to the 20th, well, 20 divided by 4 is equal to 5. The remainder is 0. So I to the 20th is just equal to 1. 32 divided by 4, well, that's going to give me 8, right? Hello. Okay, so 4 times 8, and the remainder is 0, and so again, I to the 32nd is just equal to 1. And then the only one that's going to be actually probably worth something is I to the 14th. So 14 divided by 4 is equal to 3.5, so remainder of 0.5, so I to the 14th is equal to I squared, which is equal to a negative 1. So now we just have to fill in all those blanks, okay? So for these two, we don't have to do a whole lot, right? Because those just equal 1, so we get x plus 2y, okay? And then over here, we get minus x, right? Because negative 1 times x will give me a negative x, and then look what ends up canceling. These bad boys right here. And my answer for this guy, because we didn't get to it in class, is equal to 2y. Okay. Any questions on that stuff, you guys feel free to ask those in class as well. All right, so the last part of the lesson, okay? It involves complex numbers, all right? So here's what a complex number looks like in standard form, where the a is the real part, and b is the imaginary part, right? It's the part that is being multiplied by the I. Okay, so that being said, right, we must have our answers in standard form when we solve these. Okay, so what are we doing down here? Well, it looks like we're either adding, subtracting, or multiplying these complex numbers. Okay, so let's remember about complex numbers when we're multiplying and we're adding and stuff like that is we're still looking for like terms here. Okay, and so the only thing I'm going to add is going to be the 2i and the 3i, which gives me 5i, and then negative 1 plus 3 will give me a 2. Okay, so my answer to the first one is 2 plus 5i. Here, make sure you distribute that negative sign, so we get 2 minus 3i minus 3 plus 7i. And so my answer ends up being negative 1 plus 4i. And then finally here, 8 minus 3i, 8 minus 3i. Multiply those two together, end up getting 64 minus 24i minus 24i plus 9i squared. Okay, and this is where we have to utilize that cycle of I in order to solve this out. Okay, so notice we have a I squared back here. So let's simplify this. 48i plus 9i squared. Okay, so remember I squared is just equal to a -1. So now we got 64 minus 48i plus 9 times -1. And so 9 times -1 will give me a -9. So 64 minus 9 is 55 minus 48i. And that is our answer. Okay, so I apologize with the length, guys. Good luck.